Hi everybody. Today we're going to work on the normal distribution and just go through a couple problems on that with the pictures in, and I think you'll get a better feel for it. So we start out with a statistics department states that the average grade in its intro stats course follows a normal distribution, and that should actually be with a mean of 74.8 and a standard deviation of 8.2. We select a student at random. So whenever you have a normal distribution, you always have to be given the mean, mu, and the standard deviation, sigma. So in this case, the mean is your 74.8, and the standard deviation is 8.2. So we select a student at random. Find the probability that his or her score is between 70 and 80. So you've got the probability that x is between 70 and 80, and we're going to use our new formula, that is x minus mu over sigma, and you can operate on both sides of the inequality, and that's fine. So you have 70 minus mean mu of 74.8 over 8.2 less than, and the x goes to z, less than 80 minus 74.8 over 8.2. So then this simplifies to negative 4.8 in the roof over 8.2 in the basement, less than z, less than 5.2 in the roof over 8.2 in the basement, and that scales down to the probability that z is between negative 0.58 and positive 0.63. So if we scroll down a little bit, there's the picture to it. Now you notice that the shading is on both sides of the zero line, so that means we're going to add two pieces of probability. So you're going to have the area from minus 0.59 to 0, and then split that at the zero line from 0 to 0.63. But because of symmetry, the area from negative 0.59 to 0 is the same as 0 to 0.59, and then you use the second piece, the probability that z is between 0 and 0.63, and you look those up in the new table that I just gave you Tuesday night, Wednesday night, and you get 0.2224 plus 2357, and that'll give you 0.4582. Okay. Now let's look at the second one. We have find the probability that his or her score exceeds 82. So in this case, you only have one place to use your formula. You have the probability that x being the scores, or the score, singular, is greater than 82. So you're going to have the probability that z is greater than 82 minus mean of 74.8 over 8.2. And that's the probability that z is greater than 7.2 over 8.2. Oh, sorry about that. Went wild with the scroll bar. So you have the probability that z is greater than 0.88. And here's your picture. So it starts at positive 0.88 and essentially goes to positive infinity. So when we look at that, we have everything to the right of 0.88. Now when we look up our stuff in our table starts at 0 and moves to the right. So when you look up 0.88, you're getting the value from 0 to positive 0.88. Well, that's not what I want. I want the area on the right-hand side. So what I'll do, I'll take the entire right-hand side from 0 to positive infinity, and then subtract out the area from 0 to 0.88. So I have 0.5, which represents the right-hand half, minus 0.3106, and that's equal to 0.1894. And that's it.